Let's talk about stoichiometry again. I know, I know. All right, I feel you. I feel you. Stoichiometry is not that great. I understand that. Everybody has a difficult time usually with it, but we're gonna try to break it down again. But what we're gonna try to do this time is that we're gonna try to do look at ratios again. But we're going to look at limiting reactant, okay? We're going to use a similar result as I did before with the silver. Silver is usually the kind of go-to for a lot of these initial reactions. And we can branch off and do the several different other examples. Let's do that. Let's go ahead and start off. Let's do silver nitrate plus sodium chloride. This is going to give me AgCl plus NaNO3. Okay? So the problem would be, let's look at limiting reactant. How many grams of silver chloride is produced when 10.2 grams of silver nitrate reacts with 2.3 grams of NaCl. Okay. All right, so we need to figure out a few things with this, okay? First and foremost, what are they even asking? What are they even wanting? There's so many words attached to this. We're just like, what, why? Why do I need to keep going? Gotta stop right now. I want to stop right now. Well, we need to keep going forward. So, in order to figure this out, remember a good rule of thumb: when we have no idea where to go, convert the modes. This is one of the very first things that you're going to want to do with this. But one other key thing that you need to remember, or that you need to know, is in order to figure out the limiting reactant, the ratio of the reactants need to be 1:1. It's very vital that you remember that the reactants need to be 1:1. In this case, it's a 1:1. I'm going to show you a case where it's not always 1:1, okay? So if we try to figure this out, what we first and foremost need to do is figure out what is the molar mass of silver nitrate. The silver nitrate, I believe we looked up last time, was around 169. Let's just go and check that again. So we'll do 10.2 grams of silver nitrate. Okay. Yes, 169.87. 1 mole. This will give me 0.060. Okay. So 0.060. Now, if we're looking at significant digits, remember the lowest one in this case is 3. We could do another 0, okay, because these are what's significant. And this is moles of AgNO3. Okay. Now we want to look at sodium chloride. I asked, it was 2.3 grams. So it's going to be 2.3 grams of NaCl. Okay. NaCl 35 plus 23, should be around 58. So let's say 58. Grams per 1 mole. Do that calculation. .396. In this case, we can do 0.040 basically. Okay, so 0.040, and then we got 0.06. So this is our limiting, right? So what we're going to want to do now is take the limiting and figure out how many grams, okay, of product that we're going to get in the end. Okay, so what we can do is 0.040 moles, all right, of NaCl. Now the ratio of NaCl to the AgCl, or even the NaNO3, was 1:1. So if we want to figure out how much AgCl, we can figure that out. We can do 0.04 moles of NaCl is a 1:1, so it's 1 AgCl for every 1 mole of NaCl. So we effectively have 0.040 moles of AgCl. Since we have that many moles of AgCl, we can figure out its overall molar mass. So we can do 0.040 moles, and we can do a molar mass of AgCl, or silver chloride. .143. So we need the grams. So 143.318 grams per 1 mole. This is going to give me 5.73 grams. And so that's 5.73 grams of AgCl, sorry. That's how many grams of that would produce.